welcome everyone to the TruTops Boost webinar. I want to thank everyone for coming. My name's Kevin Cusio. I'm a product sales engineer for Trump, focusing on our TruTops software portfolio. And for this webinar today, it's going to be a brief overview of our offline programming software, TruTops Boost. It should take anywhere from usually 45 minutes or so. Everyone is on mute. I'm the only one with the microphone turned on. If you do have any questions, please feel free to use the questions pane that's built into the GoToWebinar control panel. Just type anything in there, and I will be looking at that box ever so often as I'm going along. So I'm going to start with a brief slideshow just to kind of go over our focuses while we were developing this platform, and then I'll get into a live demonstration of the software. If you have any questions, or maybe you joined for a particular reason or want to see something specific, please feel free to use that questions pane to let me know as I'm going through the slideshow. If I don't see anything in there, then I'm just going to go through my general workflow, which will basically highlight laser and press break. Okay, so I'll go ahead and get started. Okay, so a little brief history lesson about Trump. We are primarily known as a machine tool company, manufacturing CNC machines. However, we are also a software development company, and we've been involved in software development since 1979. So it's nothing new to us. We first started our software developing venture on our machine controls with our shop floor programming capabilities, being able to process parts or program parts to some degree directly at the machine control. Some of our technologies have a little bit more capability than others when it comes to that, especially our press brakes being the most comprehensive shop floor programming machine. However, either way, all of our technologies have the same two challenges: complexity and profitability. So you are not able to run the machine and program it at the same time, so it does a loss to profits. Also, depending upon the complexity of the part or nest, it will either take longer at the machine or it may not even be possible at all. So that's when we moved to an offline programming platform. About 30 years ago, we came up with our first offline programming platform under the TOPS umbrella, which evolved into TruTops and has moved forward from there. Either way, with that technology, we had several different softwares for all the different functions and technologies that we offer, like a drawing software, nesting, lasering, punching, bending, flattening. And over the course of those nearly 3 decades, the manufacturing industry has evolved quite a bit. So that older platform we had, although still very powerful, we still have plenty of customers using this classic software even today. But there are certain challenges that that platform just is not able to work around. Some of the biggest ones: running smaller lot sizes with shorter lead times, using various data formats and file types, and somehow keeping track of all that order and part information. So that's when we decided to develop a new platform to focus on the challenges of our previous solutions. So the first thing we did was we brought in an order management system where we would follow a very basic workflow that nearly any company can follow when manufacturing, regardless of what the part they're physically producing. So if you're in sheet metal, you start with an order, you attach a design or part to that order, make sure it's cleaned and ready to go. Once the geometry is prepared, you would then make sure you can perform a successful bending solution if press brakes are involved. And then once the press brake program's proven out, we move to nesting and cutting, either for laser or punch. And then once everything's proven out for the different technologies, we would release the respective NC out to the machines. Okay. Another focus was combining the technology into one true platform. So rather than having a drawing software, a nesting software, and a cutting software, and a bending software, etc., we wanted to make it so one programmer or multiple programmers can be within the same system, sharing the same database and processing for all the technologies. It makes it easier and more transparent to keep track of the work that's going on and go through this workflow when everything's in one system. And then automation was another big focus of ours as well. So we wanted to automate the software as much as we could and really wanted to focus on redundancy in the programmer's daily activities or tasks. So especially with things like, let's say, preparing geometry, rather than opening parts one at a time and then saving them or cleaning them after, and then saving them as a DXF, we wanted to make it so you could batch import geometry and automatically clean multiple files at once. Same thing with programming. Rather than manually create a program for a press break, automatically create a program for multiple press breaks simultaneously. And then rather than manually nesting parts on a sheet, automatically nest on the sheet, automatically create the processing and sequencing and optimizing, and automatically generate the code. So that's really our biggest focus, was automation and transparency throughout all those processes. All right, so Boost is not brand new anymore. It's been out for nearly 5 years in the North American market, about to hit 6 years in the European market. So it is our main software package going forward. We're putting all of our research and development into Boost, and this is going to be our main software package for offline programming. We're still going to support TruTops Classic. If you have it, don't worry, it's not going away anytime soon. However, it's no longer being actively developed. There's no longer any new versions coming out for it. All right, so what we've done is we've split the software into 2 different levels: Home Zone and Tech Zone. Home Zone is your automated area. This is where everything is going to be centrally managed, all the parts, the orders, the jobs that are being produced. It's also where all the automation is happening, like the automatic preparation of parts and automatic nesting and programming and bending. Tech Zone is the interactive level. So this is if you need to go in and make a change to geometry or make a change to a bending program or a nest or processing, we still have the power, just as much, if not more power and capabilities than our older TruTops Classic system. Okay, so our biggest focuses for Boost: shorter lead times, increased productivity, better organization and use of materials, and a more flexible working environment, a higher quality software with a connected intelligence to our machines and technologies, and automating numerous functions. So coming out of the slideshow, let's take a look at Boost. So this is Boost. Right now I'm in the welcome screen. There's no programming that can be done here. However, we did want to focus on transparency to our users as well. So every time a new version comes out, we want to make sure everybody knows what's new in that particular version. And this is especially important because we are on a fast track development schedule. That means that every 6 months or less, we want to put out a major version release of Boost with new features and functions in it. So as I mentioned in my previous slides, Boost has been out for 5 or 6 years, depending upon the market you're in. And you can see here we're on version 11, right between 5 and 6 if we were to have 2 versions every single year. Okay, so in the welcome screen here, we have video tutorials, and we have a tips and tricks area. And then we have a tiled area here that just shows in every new version what was the new features that were implemented or new functions. So there's new engines that have come along, like a new nesting engine, a new bending engine, a new panel bending engine, and then a bunch of new features along the way in all of our different technologies. Then if you want to learn about any of that stuff, you just click on the tile It shows you exactly how to do it, how to use it. There's hyperlinks to get to the various different parameters involved with some of those functions. If it's a more complicated function or maybe needs to be described visually, clicking on a tile may also bring you to a YouTube link, or it may open a training website, especially if it's a very complex function where you can log in and take some training. So either way, we want to make sure that everyone's well informed on the product as new versions are being released. Okay, so coming out of the welcome screen, I'm now going to enter the home zone. So this is where we actually have work to be displayed. There's three main categories: part, order, job. And we're going to basically traverse these three categories throughout this demonstration as we perform different tasks within the software. To make it easier to find entries in the different categories, we have a search field with free text, and we also have a filter tree where we can narrow down items by different groupings, like material type, thickness, customer, things like that. So right now I'm in the part category. And you can see here, it's a very visual system. So all my parts are displayed. There's 700 parts. I could scroll through them if I wanted to. If I click on a part, I can see all the information about it. So in this case, we can see the status is it is a completed part, but it does have a warning on it. And in this particular case, this warning is that some elements of this part have splines. So it's just been optimized to take care of those splines. So it's a warning. It's not going to stop us from doing anything. We can see the name of the part. There's some blank fields here that could also be filled out with some additional information like customer notes, drawings, revisions. We can see what the part's made out of, its raw material, its allowed angular positions, its X and Y dimensions, an isometric view of the model along with a top-down view of the flat. And then if there's any cutting or bending programs assigned, and if this part exists anywhere else. So what I'm going to do is I'm going to import and prepare some parts, and we'll run it through some different technologies. So I'm going to click my import button. And here it brings me to a Windows API, basically Windows Explorer, where I can browse and through my network folders or local folders to find parts that I want to import. One of our main focuses was also focusing on the amount of file types you can bring in. So we can still bring in generic files like DXF, DWG, so generic flats. We can also bring in proprietary Trump files from TruTops Classic, so that'd be GOs, GMTs, TMTs. And we now have support for 3D models as well. So we can bring in generic models like STEP, IGES, SAT. And with certain software options, we can bring in proprietary models: SolidWorks, Solid Edge, Pro-E, Creo, Inventor, CATIA, Parasolids, NX files. It's a pretty broad list of file types that we can support. So I'm going to batch import 4 parts. So as I mentioned, we don't have to bring parts in one at a time. And the software is going to automatically prepare the parts as far as it can without any user interaction. It's going to assign a status to the part, and then it's going to display all the results of the preparation. So for 3D models, it's going to take a little bit longer than a flat because it's interrogating the model and it wants to make sure it's a valid sheet metal part. So that means it's basically importing the model, it's looking at its features, and it's making sure that it's drawn from one solid, that it's one consistent thickness, that it has consistent radius values on all the flanges. There's no overlapping bodies, surfaces, faces, or problems with that model. If it passes the sheet metal validity test, it automatically flattens the model, adds bend line data, which are these green lines. And these green lines house information like whether it's an up bend, a down bend, and what angle needs to be bent, along with the radius of the flange that was existing in the model. Okay, so here we can see a flat as well. The flats came in a little bit quicker because there's less to look at. If it's just a flat file, then it just wants to make sure that there's no overlapping contours or open contours, and that there's a clearly defined outer contour and clearly defined inner contours. If it passes the test, it'll come in. So my two flats have green check marks. They are complete. The software doesn't need to know anything else about this part before it can nest it. For the models, they both have an incomplete status. So we can see here it's incomplete, and it'll tell us why. So with any of these different statuses here, like there's an error on this part, we can see the part's not completely flat. There's an error on this part because there's several solids, and because there's several solids, it doesn't pass the sheet metal test, so it had a problem during unfolding. So it's very informative. It's a very visual system. So I'm going to prepare these models so that they are complete. So I need to assign material. Let's assign steel. Because we already measured the thickness of the model, the raw material automatically gets populated, 080 mild steel. And throughout the software, there's orange boost buttons. And depending upon which boost button you click, it performs a certain automatic function for its category. So if I boost the design, it's going to apply steel attributes to the models and then reflatten the model with the proper bend allowances and tooling combinations for that material type and thickness. And that way it'll give us a more accurate flat pattern. Okay, so we don't use K factors. We actually use bend allowance tables. So depending on the material and the thickness, there's certain tooling combinations that best fit that. And those different tooling combinations give us different flattening values because let's say a wider die is going to give us a larger radius, a narrower die gives us a narrower radius. It's going to change the stretch of the material. So that's how we determine our flats. It's also very helpful if you're involved with press brakes, because it makes it a lot easier to select tooling and tool up the parts and create programs. Okay, now that we have 4 green check marks on these parts, I'm going to go ahead and move forward and start preparing them. So as I mentioned in my slideshow, this is the workflow that we want to follow. Once the design is imported and cleaned, if bending is involved, we create our bending. So we have these 2 3D models that are going to need bending. So before I do any nesting or programming for cutting, I'm going to come up with a collision-free bending solution, or try to at least. So I'm going to create 2 bending programs, one for a 5000 series hydraulic brake, another for a 7000 series electric brake. And I'm going to click the boost button. So this is going to automatically create bending programs for this part for 2 different machines at the same time. And I'm going to do the same thing with this part as well. A 5000 series hydraulic, a 7000 series electric, and boost the programs. While the software is automatically determining bending solutions, I'm now going to take these flats and start preparing them for nesting. Okay, so we don't need to do a bending step for those flat parts, so we're going to skip over straight into the cutting platform. Okay, so here's our order management area. I created 2 orders for us to work with, one for each part. And this is where I provide my order information. So let's say they're due tomorrow. I need 10 of each. They're for the customer Trump. They're part of a kit or an assembly. I can set my rotation angles or change part information if I want to. But we'll say that's good enough. So now I have all my order information filled out. And this order information is extremely helpful for keeping track of the quantities you're nesting and other information like notes or assembly or customer information. Now with just 2 orders, it's not really all that helpful. It's easy to see the 2 orders and just look at them visually. However, if you have an ERP system or MRP system and you've decided to integrate that system with Boost, which is possible, you might have hundreds of orders in the system at any time. And now it becomes increasingly difficult to narrow down these orders and nest them together in a way that makes sense for your company or the product you're producing. So this is where my order management system comes into play and where the filter tree is very useful. So we can see here, I have my filter tree. I'm going to search for all my missing and open orders. So out of those 550 orders, only 150 need to be nested. And out of those 150, 17 are open for stainless. And out of those 17, 6 have an 060 thickness. And out of those 6, 2 are for the customer trump. Or I could say, show me everything that's due this week. Or I could do a wildcard search and say, show me everything that's part of the kit or assembly that has ABC in it. So I can use a number of different filters to narrow down my order queue. Now I'm going to take those orders that match my filter criteria, and I'm going to create a job for them. Okay, and here we can see my order list and all the information about the parts in my order list. And I just need to fill out all the information down here in order for this boost button to become active. So I'm going to pick a machine I want to process the parts with. And you can see here it's loading my rules. So you can see there's 2 gold stars, one for a profile, one for a tech table and rule. And these are going to work together to automatically create nests. So my profile is going to have information like my sheet margins, my web width between my parts, my sequencing direction, my type of movement or traversing between parts and contours, the nesting engines and algorithms I want to use, sheet cut parameters, microjoint or tabbing parameters. There's well over 100 parameters in there, I would say, for those profiles. And my tech table is going to be my cutting rules. That's going to be my cutting speeds for small, medium, large contours, my focus, the nozzle I'm going to be using, the assist gas, my lead-ins, my withdrawals or lead-outs. There's, again, a number of variables and parameters in here that can be customized or chosen between. Once I have my profile and table selected, I'm now going to select what sheet size I'm going to nest on. So I'm going to pick a 4x8 sheet, and I'm going to click the boost button. And just like boosting the design or boosting the bending, boosting the job is creating automatic solutions. It's going to take those parts and quantities, nest them on the sheet size that I've selected with my profile and table parameters. So it's going to use my margins, my web width, and all those different parameters I mentioned before to automatically create a nest, automatically cut that nest, and then automatically sequence that nest. Once it's done, it will then generate the NC or the LST file for the machine and display the results. So here we can see my finished results. I can see some quick information in these thumbnails here, like the scrap rate, the estimated runtime. And for this particular generation of laser, the accuracy will be plus or minus 5%. I can also see a thumbnail or layout of what the nest looks like, and a setup plan is also generated. Okay, so if I open that setup plan, we can see here what it looks like. This is basically a traveler for the operator. We can see here the machine it's intended for, the estimated runtime, who made the nest, when it's due, the waste or scrap percentage, total parts, the tech table that I'm cutting with, the nozzle that's needed, the assist gas that's being used, the sheet size and weight, overall or individual part information, and then a view of the full nest with the minimum sheet size that's required to produce it. Now in this particular case, my nest, although it's complete, we can see here the status is just saying it's missing a release. And basically all a release is this button here. And when I click the release, it sends it out to the network where the operator can browse to that same network folder, split the program at the machine, and start processing the job. Now, it will also lock the nest out. So you can see everything is now gray. I cannot change anything about this nest. I can only view it. It's in read-only mode. If I want to make any changes, I have to unrelease it, which will delete the job from the network location and bring it back into Boost, so nobody will run it accidentally while revisions are being made. Okay, so in this case, my scrap rate's really high. I can see here I'm barely nesting half the sheet. So I want to do something about it. So there's a couple different options. I can pick a new profile, maybe one that has sheet cut parameters in it, and maybe create some remainders or drops. You can see here I have a remainder created in the system already with a sheet cut. Or maybe I can fill the sheet out more or nest additional parts. So I'm going to use my order management system to view any other open orders. So it's going to automatically filter for any parts that are made from the same material type and thickness that have open orders available for them. So maybe my margins or my filter criteria was too narrow before. I was only looking for a certain customer within a certain due date for a certain kit. So I'm now going to open up my search criteria and add additional orders to the job as filler orders. So you can see here the lock is open, meaning it's going to nest as many parts as it can on the job I've already created, and it's not going to create additional scrap or nest on any additional sheets. So I'm basically filling out the job I already made. And when it's finished, it's going to display the results of the new nest with the filler orders added to it. So here we have the new nest. We can see the scrap rate dropped by over 25%. The processing time increased by about 4 minutes. And now we have our new results. And again, there's no errors, no warnings, no messages, no collisions detected. It's still a good nest that's ready for release. However, if I still want to add more things to it or make changes to it, I can go into my tech zone area. So as I mentioned in my slideshow, we've split the software into 2 different levels. Everything I've done so far has been in the home zone area. Now I'm going to go into the interactive programming area and show you what that looks like. So here's my tech zone cut. Here's the nest that the software automatically produced. I can see the parts and orders that are existing in it and how many are existing in it. I can see the different cut paths. So if I zoom in a little bit, you can see here a quick overview of a cut contour. The red asterisk is the pierce. The red circle is the estimated splatter radius of material during the pierce. The red line is the lead-in. The green line is the cut path. The green arrow is the direction of cut. And the blue lines are the traversing between contours and parts. Okay, so everything's already been sequenced. I can simulate it. I can speed it up or slow it down, or step it forwards and backwards. I can also make processing or nesting changes as well. So I can move the parts around if I wanted to. I can drag the part. You can see here I have margins turned on, so the part's gray. It won't let me violate my margins, my sheet margins, or my part distances. I can turn that on and off, but it's helpful to make sure you keep with your favorited parameters within your profile. Yeah, I can also make processing changes. So let's just say I want to make some small changes here. Let's focus on this part here. So let's microjoint it or add a tab to it. Soft coded so the operator can change the microjoint width or turn them on and off at the machine. And I want to change the location of that microjoint. So I'm going to change my pierce and lead-in locations. I'll do it for a couple other contours here. And let's just say we're a little concerned with these arbitrary contours, maybe getting hung up in the slats or getting stuck because of their shape. So let's go ahead and, rather than tab them, we'll cut them up into smaller pieces so they fall through the slats easier. And you can see here, I'm also viewing my slats as well. So my slat layout or my table is here. So the software can use that to determine if anything is a tilting hazard and react to it accordingly. Okay, now that I've made those changes, I'm going to save this part. And that's going to put the part back into the home zone as a cutting program. So the text zone and the home zone, although they're different windows, are interconnected with one another. And if I go back and view that part, you can see here, there's now a cutting program saved for that 3035 laser. And now the next time I nest this part or create an order for it, or it shows up in a job, it will automatically use the cut path, those micro joints, those scrap cuts, everything that I've added to it, it will automatically nest with that. Okay, now that I've made some processing changes, let's spread the parts out more evenly, do some distribution. Okay, and one last thing, rather than have a large skeleton to deal with, whoever's responsible for the part separation side of this after the sheet is cut, go ahead and make their life a little bit easier and safer by throwing in some grid cuts. Okay, so this is going to automatically cut the skeleton into smaller, more manageable pieces. So when your part separation occurs, rather than wrestle the skeleton and try to fold it up and put it in a bin, it's just going to come apart in pieces as the parts are removed. Okay, so I'm going to rewrite the code, save and exit. And all those changes I made are going to go back into the home zone and update my job. Okay, so here's my finished results. My processing time increased by about a minute, maybe a minute, 10 seconds. And now I'm going to release the job now that I made those processing changes. So again, it's going to send a copy of the program and a copy of the traveler out on a network folder where an operator can find it. Okay, if you have any questions about the nesting, the cutting, the laser processing, or anything to do with the cutting technology, please feel free to use that questions pane. And while you're typing anything in, I'm going to move back into the part area. And let's overview and look at the bending programs that I had automatically created in the very beginning of the demonstration. So here we can see the results of the two parts. Again, it's the same icon, right? That same status, the blue circle with the white arrow, meaning there's programs ready that need review and release. So here I can see my finished results. There's no errors or collisions or problems. If I drill down into the program, we can see here there are a few warnings announced. So there's 3 bends where there's holes that are close to the bend line. Not going to hurt anything. No collisions, no risk of, fatal, injury or risk to the operator. However, it still wants to make me aware of something. So I'm going to open up the program in the text zone bend area. So you saw the text zone for the cutting. Now I'm going to show you the text zone for the bending. Okay, so here's our text zone bend. Here I can see the bend sequence and any issues. So I can see mostly everything has check marks except for these 3 bends with the yellow warning. So let's click on them and I can rotate this and look around. So if we see here, basically it's warning me of these holes. We can see they're very close to the die shoulder, basically inside of it. This radius is more than likely coupled with the die shoulder going to blow out these holes and maybe deform them. So if you need perfectly round holes there, you should do something about it. If not, you can ignore the warning and just run the program as is. So let's fix it so we don't get that warning anymore. I'm going to change my tools, my lower tools. And you can see here, everything on my tool list is showing, okay? And if I hover over these tools, it's going to tell me if there's any issue. So it's automatically collision checking the tooling that I have and letting me know if it's possible to use it or not. So I'm going to try and use a 10mm die. So we can see here, if I use an acute angle die, we're still going to get that issue. But if I use a 90 degree, or I should say 86 degree die, there's no errors or there's no warnings anymore for that. And because they're all 90 degree bends, you don't have to worry about having a collision or bottoming the die out. Oops, let's refocus here. Oh, where'd it go? There it is. Sorry, there we go. Okay, so now I'll simulate the program with that new 10 millimeter die. And let's show the full machine here as well, just so you can see it. Okay, so here's the full machine, and here's a simulation of the program that was generated. Oh, let's start from bend 1. I'm sorry. So here's starting from bend 1. The tooling, the back gauge positioning, the part rotation and handling were all automatically calculated by the software. Okay, so there's our finished result. Everything looks good. I'm going to rewrite the code and exit just like I did for the laser side. And it's going to push that updated program back into the software. Now, one of the reasons why we say to do the bending first is, first and foremost, you want to make sure you can actually produce this 3D model on a press brake before you cut the flat. But also, when I change that die, as I mentioned, we don't use a K factor. We use a bend allowance. So even though the angle is the same and the material is the same, when I change that lower die, I changed my bend allowance. If I use a narrower die, I'm going to get a smaller radius, and I'm going to get a different stretch on that material. So the software is warning me that because I changed the lower tool, the flat no longer matches the bend program. So keep an eye on the dimensions here, the 6.6 by 8.33. I'm going to update the design. And what that's going to do is it's going to push those bend allowance tables back into the model and re-flatten the model with the proper dimensions. So you can see here the dimensions of the model changed. And I'm going to update my bending program real quick because the tooling doesn't match anymore on that second program. And you can see here how quickly the software rewrites a program. So it's adding in the new die, re-simulating, optimizing and rewriting the code for the machine based upon those new die or the die change I made. Okay, now I can release it, and those programs will now be waiting out on the network. So when that flat gets to the operator, they're going to have that program ready to go. And in the Traveler, certain press brakes have a barcode scanning option, and if you have that option on your brake, or you get a brake with that option, rather than browse for the program, the operator could just scan this QR code and it'll automatically bring the program up at the machine. Okay, so that's just a quick overview of TruTops Boost, a little bit of part creation, order management, nesting and cutting with a laser, and bending with a couple different press brakes.